Hi everybody, in today's video I would like to try something a bit new, and that is I found on the Android Play Store, on Google's Play Store, this application right here, which is a simple joystick control for my phone. So as you can see, I can move this joystick around, and this is a so-called UDP joystick. So this is basically a remote control that I can use on my phone, and I would like to code an application in pure C in scope of this video that I can control using this joystick. I have no idea if this application even works. Maybe it is outdated and something doesn't work anymore, but we will find out in this video, and ideally at the end of this video we should be able to use this control right here, this joystick, to control something on the screen, on my local computer screen. And ideally it's something graphical that we can control. So maybe we should start with coding some very simple graphics application, and then we will embed a UDP receiver that receives UDP packets, and then we will control the graphics using this joystick. Or maybe we should start with the UDP receiver. Maybe that's the more interesting start, and then we can just quickly build up the graphics. So let's create a new directory, and let me call it joystick, or a UDP joystick. No, let's just keep it joystick. Let's keep it simple. And then let's create a file that's called joy.c, and let's include standard.io.h. And as always, let's start with a simple hello world statement, just to verify that we can compile the application. There's our print statement. Let me go over to this bottom right pane, and here we will go into the joystick directory and call gcc. Out file is joy, the in file is joy.c, and then right after compiling we can execute the file. And one more detail that I want to add here in the compilation statement is I want to add the G flag for debugging in case we need to debug something. So this adds the debug symbols, and W also, that the compiler definitely spits out all the warnings about the code, because more often than not, this will save us some troubleshooting. And as you can see, it compiled the code here, then executed it, end execution, and then we get this printout hello joystick. So that works. That's already quite good. Now, as a next step, maybe let's start with the UDP receiver, and for that I need to open a browser and have a look at UDP receiver in C. And I've already clicked all those links because in one of the last episodes, I think 2 or 3 episodes ago, we coded an application that was able to send UDP packets to my phone from the terminal. But now we want to do the reverse. We want to make this application a receiver of UDP packets. So I have to look up things again. But we can keep this quite simple. What we need to do is we need to have a UDP server or client. I think the client is the one that sends messages and the server is the one that receives messages. So we need a UDP server. And we need to, let me just see what we can take over from this code. We need to bind. And let's create a new terminal here and use that to look up stuff in the manuals. So we can use man bind to look up documentation in case we need to. So this would bind a name to a socket. Basically, a socket is a file that, at least on Unix-based systems, it's a file that, when written to, will output the data to a network driver. So whatever we write to the socket is being sent eventually. Or if we bind to a socket, we listen for changes in that file, which is actually data incoming from the internet via UDP. And yeah, we received those changes. We received the data, I mean. So I'm a bit overwhelmed with the documentation here. It says when a socket is created with socket 2, it exists in a namespace, but it has no address assigned to it. Bind assigns the address specified by address to the socket referred to by the file descriptor sockfd. Okay, that's not really helpful right now. Maybe there's an example at the bottom of that man page. I have seen plenty of examples sometimes. Oh, and there is an example. And I would say any examples that are in the official documentation of in the man pages in the operating system itself, we can take them as good advice and just copy them. Maybe let's not copy them one-to-one, but let's get some inspiration here. But what is this code actually doing? We can accept incoming connections one at a time using accept. Okay, but where's the bind? There's the bind. So here, this code is trying to bind something, and it passes my address, and then the structure of a socket address. Yeah. One thing that we can do for very sure is we can import the socket.h. So as you see, I have basically no clue, but I'm setting everything up step by step until we arrive at the very goal that we made up at the beginning of this episode. So let's include sys socket, and it needs to be socket.h. And then we need to bind something. And we need to bind, what do we need to bind? A sockfd, then a socket address, and a socket length, address length. So I can probably just get all of that and copy it, go over to this terminal, and then let's paste it here. Of course, this is now the prototype with all the data declarations, which we don't need, but this is a good starting point, I would say. So we are trying to bind something. It returns an integer, and that is probably an error code. So let's just call that error code, or maybe error. Let's call it error code. And we try to bind to a socket file descriptor. Okay, because every socket is a file. Then we pass a socket address, which I'm not sure of because we don't specify an address, because we want to listen to all incoming network requests. So whoever sends us stuff is being listened to. And then the last argument is the address length. I don't know actually what this is used for. Why do we need to specify the address length? Because all the data should already be stored in the address. But there's always a reason for the API to, especially for those basic syscalls, for how they are laid out. And let's have a look. So address length specifies the size in bytes of the address structure pointed to by address. Yeah, but does the bind command not know that this structure is being passed, and because it has fixed size fields, it knows about the size? No, I think it's because this is a pointer. So maybe this could be could this be a list? I think we have to look up the socket address. Wait, man sock address. No entry. Am I looking up the wrong thing? Sock address. I think I probably also have to include the type. So before I forget it, let's do that as well. Let's include sys_types.h. And if we can't find something in the manuals, if we can't find a type in the manuals, then for sure it is defined in... Let me show you where I think it is defined. It should be somewhere in user lib. It's user lib, which stores all the libraries that are installed on this machine. And then we should be able to grab -rli to only grab the non-binary files, text files basically. And then we can ask it to give us the header files for... we can actually look for the header file directly, so we don't need the grep command, but we can do find.-name and then types.h. There are a couple of types here, but I think I'm in the wrong directory. Wait, which directories are there under user? Include, local, maybe, include? I think it's include, not lib, because here I can see the system libraries. Okay, let's try to find it here. And there are a couple of types.h files, and one of them should be the system types.h, and there it is. And here we can look for, what do we need? We need the socket address. Sock address. It's not available. Okay, before I waste time doing some useless lookups, let's have a look at this code here. So we want to bind to, well, here's the listen file descriptor. What is it? That's a socket. Of course, before we bind to a socket, we have to specify what the socket even is. And yeah, so let's also create a UDP socket, and I think we have already all the imports for that. I don't know, we will see. So let's go down here. So, and I will call this returned int, the socket file descriptor, or the socket ID. The socket ID, I will call it the socket ID. We want to create an AF internet socket. This is the regular IPv4 internet socket as far as I know. We can look that up. Is there anything here? Yes, there is plenty of things there. So let's open that file, AF inet. Yeah, so those are the address families, and there's AF inet, which is the regular internet IPv4 address, but there's also most of those you will never need in your life, except you definitely know that you will need them. There's, for example, interesting stuff such as Bluetooth here as well. So that's nice. And I think there should be AF and then something internet IPv6 for the new generation of addresses. Or am I wrong? No idea, but that's my understanding. So, and then we want to use we want to specify the kind of packet that we will send, or the kind of protocol that we will send. So let's look that up by calling the man page of socket. Yeah, we want to specify the domain, basically communication via internet, IP. And the type is, there's more documentation here. Yeah, and the type that we specify is a dgram. And this is basically saying that we want to use this UDP protocol. This supports datagrams, and UDP stands for, I think, Unified Datagram Protocol. And a datagram is basically a packet of data. It's a telegram with data. So that's where the name comes from. And if you don't want to use UDP, then you specify socket stream, which is TCP. And TCP is the internet protocol that you use when you want to send data and you want to be absolutely sure that the data arrives, and you want to be absolutely sure that the data arrives in order. So this is the big difference between TCP and UDP. Basically, for every application that you're going to code yourself, you can just use socket dgram, because TCP has a lot of communications overhead, and unless you really want to be absolutely sure that you need this, you can just default to UDP. In UDP, sometimes packets are lost, sometimes they arrive out of order, but for things like remote controls, which send maybe 200 packets a second, there's no issue with occasionally losing a packet. Yeah. So, for example, TCP is used for spacecraft communication, for example. So I'm working in the space industry, and there we want to be absolutely sure that a command to a satellite arrives. And so, yeah, we always send stuff using TCP, or actually protocols built on top of TCP. But the basic protocol that we use for the communication is TCP, because data can't be afforded to be lost. All right. So then we create a socket here, and the first argument, we have already clarified that now, is the socket ID, which is our file descriptor. So now here the operating system creates a file which is interfacing actually with the internet, but you don't care about that as a developer. And here you say you want to write data to that file descriptor. Now the next argument is the socket address. And this socket address, we need to find out what that is. The address is, no, wait. Okay, no, that's fine. This socket is established. That is good. The socket address that we pass is coming from the other min page here, from the bind method. And the socket address, let's look up in this code here. Where is it instantiated? Yeah, so here, this guy or girl, right, creates this server address structure, and it's not initialized yet, but then the data inside that server address is instantiated manually. So here, first an IP address is filled, then a port is made available, and a socket an internet socket family is specified again. And as you can see here, there's a difference between the socket that we instantiate. This is a socket address internet, and there are different types of those socket addresses. And in the bind method, because this is a generic method and it can bind to multiple different types of sockets. For example, it could also bind to an IPv6 socket address, which would have a different type. So here the bind binds to any socket address, but we can cast it. We can provide our socket address internet IPv4 address here and then cast it. Yeah, I don't know if that's even the best practice. What we can do is, no, that's fine for this video. I think there are better ways to create this server address, and I saw one in a guide. Let me look it up for you. Right. So there's this guide on network programming which I started reading. It's called BJ's Guide to Network Programming. You can look that up online, and there's this function here, get address info. And here this book says, this is a real workhorse of a function with a lot of options, but the usage is actually pretty simple. It sets up the structs you need later on. And here this guy just specifies here you can specify an internet address, then a type of service that you want to use, and some hints, what you want, maybe the protocol that you want to use, and then this function fills the result pointer. But maybe this is too complex for this video. Yeah, I'm too stupid for that right now, so let's go with this traditional approach here. So let's not autofill the information, but let's try to set it up manually. We will just create a structure that is the address, and let's keep it simple as we can. So we want a server address, and eventually we're taking this, maybe let's call it just sin address. And eventually we're taking the socket address, and then we are passing it in here and casting it as a, what type do we need? Constant struct socket address pointer. No. So we cast it to, wait, I need to close the window. Neighbor started mowing the lawn. Okay, and here I am. So we need to cast it to a constant struct socket address pointer. Constant struct socket address pointer, and we're going to pass as input the address of our sin address. So here the address, as per the C standard, is not to be confused with the internet address. So we're passing the address, a pointer to an address. But those are two different kinds of addresses, so don't confuse them. And then at the end of this, we're passing a length, which I'm still not sure about. What does this guy here pass as the length? Size of server address. Yeah, I'm a bit confused what this is needed for. Maybe this is needed because we can pass different types, different structs in here. I don't know. Let's just pass the length. We can figure that out. And the length is, what kind of data type is it? It's a socket length T. There's a data type for the length. Okay. They have special data types for everything in C. But okay. Where's the... This is just an integer here. Length. Wait, we bind and we specify... Ah, no, this is the size of that we need. So basically it's just a size T. It's confusing. That's really confusing. Why do we need a special data type socket length t. Man socket length t. It doesn't exist. Of course it doesn't. What happens if we grep for that? Socket length t. Sock length t. Ah, it's sock length. Doesn't exist. Sock length t. Oh, and it's defined in multiple headers. I think I will look it up in the socket.h. Sock len t. Yeah, okay, but it's not defined there. Maybe it's in unistandard.h. Sock len t. Type def. Okay, and let's look up the underlying type. I don't get that type definition. Well, okay, it seems that we can just pass regular size t. This means we can just do size t and then socket length is size of sock address in, which returns the size of this structure. And we are missing a header import because here we get this error message: variable has incomplete type, struct sock address in. Why is this an incomplete type? So yeah, I would guess that a header is missing. And to find out the right header, we could just do grep-rli sock address in. And we would get a couple of headers where that is defined, I think. And the most likely one that we're going to use is, I think this one, net in or something like that. But let's look at what this guy does. Yeah, there it is, net in. So that's probably a confirmation that this is correct. So let's see what happens if I save that file. Yeah, the error goes away. So that's indeed the place where this structure is defined. And then the size of course, here we have to specify the name of the variable, which is s in address. Okay, that's good. Now the code is looking much healthier. Wait, let me also set line numbers here so we get some line numbers. I think it's better with line numbers. And then unexpected name, socket length. Yeah, of course. Of course, we have to also fill the last variable here. So the last variable is called socket length, which is now an incompatible pointer type. That means we have to wait. And now is the time for trying to compile it and see what the warnings say. Okay, warning: passing argument 2 of bind from incompatible pointer type. So it's saying that the pointer I'm passing and the pointer I'm trying to cast, the two, are not compatible. And I think I messed up this, the declaration here. It should be sock address, yeah, no. Time for some documentation again. So let's man page and then maybe bind. It was bind. Yeah, sock address. So I would say this should work. Let's see. Yes, the warning went away. And we have a different warning here. Unused variable. Okay, that's not a problem because we're yet to use it. We're going to use it. All right, I think we're now bound to a socket, but we haven't even filled this socket address array. So this will not do anything. We can, just for fun, try to execute this application, but it won't do anything. Yeah, and as you can see here, wait, let me clear that screen. As you can see here, we get the hello joystick printout, and then that's it. And nothing happens here. We can also, just to make this video more interesting, we can jump into a debugger and I can show you there what happens. And actually, I can show you that nothing probably happens. At least that's my guess. So let's cd into the joystick. And then let's use gdb joy. Layout next. And this is the source code here. Let's run the source code. No, we have to start. So we hit a breakpoint at the start of the main method. First we print hello joystick, as you can see. And then and now we're in the last line. Let me just ensure this, yes. We're in the last line, and here I can say print SID, the socket ID of the socket we initialized. And it's minus 100, no, not 100. It's some big integer. Okay, fine. So this could actually be a valid socket, but the issue is with the socket address, with the S in address, which is this empty structure. And if we print that, then as you can see, all the fields of this structure are 0. So we haven't specified the internet family, we haven't specified the port, we haven't specified the address that we're going to use. And then there's what is this? This is a buffer of just zeros. This is actually intended to be just zeros here. And that is something that we don't need to bother with much. This is just for making this structure castable to the other types. So we need to instantiate the socket address in properly. And maybe we can even do that with the debugger now. So we need to set socket in family. And this is actually duplication a bit. So as in family, and the family is AFINet. It's the same family as for the socket here. Then the S in address. What else do we need? We need the S in port. We need to set that, and we need to clarify how to set that in a couple of seconds, because I think we can't just set a number. Let's just set a number, and as you can see, there's an error. There's no, it needs to be S import. Oh, there's no error. Maybe it can be a number. I thought it couldn't be a number. At least not a plain number that is not polished. And then we need to specify the S in address, and the S in address contains another S address, which is then the actual IP address. So S in address, S address. Wait, S in address contains a field that is called S in address, and that contains another field. So we need to call S in address, S in address, S address, I think like this. And then we need to specify the IP address here. And since we actually want to use to listen to all incoming IP requests, we use the in address any constant. So let's copy that thing here. And now you're probably wondering what this H2NL stands for, as far as I know, this stands for host to network long. So depending on, all communications in a network are done in a so-called network format, and that network format of the bytes that we send on to the network is big endian. That means that the data we write into the network arrives in that same order. But our processors, sometimes, depending on the processor you have, Intel, for example, uses a so-called little endian order to store things. So here, this method ensures that we are specifying the address in the right format, which is the network format, big endian. So in case your system is already doing things in big endian, you won't need this method. But in case it is storing bytes as little endian, you need to, this will fix it up for you. So this is for making the network code portable. And I think, I'm not sure why this is using the H2N, the host to network long method, instead of the host to network short method, because this one also exists. Maybe because this is now compatible with IPv6, I have no idea. But it's something like this. If you know the answer, please put it in the comments. Yeah, as you can see here, the port is H2NS, so it's using a short. Maybe that's because, a long is 32 bits, which is 4 bytes on most systems, and an IPv4 address fits in 4 bytes. And a port is just 2 bytes of information, so we can use the short here. That would be my best explanation right now. So let's call H2NS, and this is our port. We can also define it up here. Define port, and the port will be 1, 2, 3, 4, 5. And of course we don't need a semicolon here, and then port. Good. All right, now we have set up all of that. We're now listening to all of that stuff, and actually for completeness, we should zero out the S in zeros. And I don't think that this internet guide does that, or does it? Oh, it does, here. It zeroes out the entire structure beforehand. But actually you only need to zero out this individual field. Well, there are multiple ways to do things. Let's try to S in address and zero out the zero field. S in zero. S in zero. And how do we zero that out? We can, let's see if we can just use the same method, or do we use something else? B0. Maybe we can use memcopy. Or we can just zero it out manually. B0. Yeah, this looks very convenient actually, B0. Yeah, let's do that. And here we pass the address, not of S in address, but of S in 0. I hope this actually returns the address of the S in 0 field. Can we check that in the compiler? Print S in address, and we print the address of that. Wait, the address of S in address. This is the address, and if we print the address of S in address S in 0, Yeah, this returns a different address that is incremented by 8. So this indicates that this is actually the right way to access this field. And then we pass in the size of s in address, s in 0. Just like this. Okay, very nice. And B0 is not defined. Let's try to quick hack our way to find out where it is defined. And I can also look it up online. But let's just quickly do a grep here. And it's part of string.h. This would be my best guess right now. So let's do include string.h. So here I'm trying to separate the basic standard C libraries and the actual internet libraries. And it seems to be not found. Why is it not found? Is B0 not found in string.h? Vim string.h B0 explicit. Oh, there's an explicit B0. Ah, that is for zeroing out a string. What about strings.h? B0 set n bytes of s to 0. Okay, maybe it's strings.h. Yeah. But what is the difference between string.h and strings.h? Can someone put that in the comments, please? That would be very interesting to know. And now let's compile, and we get the warning that this variable here is unused. And aside from that, we get the hello joystick printout. But now we can call all of that in the compiler, in the debugger. Yeah. Wait, where am I? So the debugger, layout next. Here's our source code, and now let's start the application. Let's run through it. And let's see. Now let's print s in address. And as you can see, these values here are filled. We have, as you can see, this port is quite odd. Probably because in my case, it shifted around the order of the bytes, and that's why we need the special h2ns call. I don't know. And the in address any is just a 0, apparently. And the s in 0 is not zeroed out yet, so we can press n here, and let's print s in address again. And now, as you can see, it's zeroed out. Nice. It just got longer somehow. But okay, who needs to care about that? Then let's create the socket, print SID, and we have a socket with an ID 3, which is a good sign. And let's hit next and check the error code, and it's 0. And I think this is good, man bind. And the return code is on success, 0 is returned. That means our application is indeed listening for messages from that socket. That's great. Okay, now my computer crashed and I had to reset up everything. But in the meantime, what have we just done? I almost forgot already. So we have confirmed that this bind method works. This means that now we have to check for incoming messages. And we can do that. How do we do that? We don't send to, we receive from. Do we just, wait. This right here is the server code. Then we receive from the listen file descriptor, which is our socket, I think. We provide a buffer to write into. This is a 100 characters character buffer here. Then we provide the size of the buffer, 0 something something. And okay, in any case, we probably need to receive from. Okay. To do that, before we do anything, let's look up receive from in the documentation. And here we get the following info. Receive a message from a socket. Oh, there's even a receive message. So maybe it's worth finding out what the difference here is. Receive message receives a message header structure. Let's not bother with that and just pass a buffer here. Okay, we need to receive stuff from. It returns an S size T. There's this is again another size data type. So I've used size T before. We have had to. Yeah, no, there was also a socket size T, which we encountered earlier, and now there's an S size T. So whatever the difference here is, no idea, but probably they are all very, very similar. If any one of you has an explanation why we need so many data types, and they are even specific to the libraries that you use, even those very simple data types, please let me know. This is really flabbergasting me. Okay, we will receive from. We need to provide the socket F file descriptor. Let's do that. Maybe let me just ensure that you still can see the entire code, at least the relevant parts. Maybe like this. Okay. Receive from. And now we have to pass the file descriptor, the S ID, the socket ID. Then we pass as input this buffer here. We don't have a buffer yet, so maybe we have to create one. And here it's just a void buffer. And I don't know actually which data or what kind of data format we are expecting from this joystick application. Wait, so again, this is the joystick application that we're trying to interface with. And as you can see in the top row of this joystick application, there are 4 numbers, 2 above each joystick. And if we move the joystick, the numbers here change. I hope you can see this. I think you should see it now. So I would expect that we have 4 integers that are being sent. But there's no documentation on that application. So we have to receive from a buffer. And I would say we expect. What do we expect? Either 4 integers or even shorts. But in any case, it can just be an array. Should we allocate memory using malloc? I don't know. I don't like arrays in C so much because they are just a bit annoying. Maybe. Yeah, let's allocate an int buffer, and that is malloc. We have to cast the results. We receive it using malloc, and then we specify that we want size of int multiplied by 4. I just hope this works. I have no idea. And maybe because this is operating system dependent, but the joystick sends some fixed size, maybe let's look up. Maybe we should use a fixed size data type such as uint 8 or something. I think there are those data types in C. Wait, uint data types in C. Yeah. uint 16t. Maybe it's, we just have to guess what kind of numbers this buffer will contain. Basically, we have to guess what the application sends, and if it doesn't work, we have to maybe check the byte data and then see what it contains. Okay, and where is this coming from? I think those data types are coming from, they are coming from standard lib.h. Yeah, and then we pass the buffer here. And let's have a look at the documentation again. So we receive from the socket data that is written into the buffer. We expect a certain length. The length is 4. And I will also create a variable for that, size t, and that is the length, or expected length. And that is 4. Maybe we can even create a macro for that length, some global constant. But for now, let's keep it here. Expected length. Then flags. We don't need any flags. Usually when there's a flags field in some method and I don't know what it's good for, I will just pass 0 and it's completely fine. We can have a look at what the flags even do. So here, the only difference between receive and read, whatever that is another system call, is the presence of flags. With a 0 flags argument, receive is generally equivalent to read. Okay, fine. But what are those flags? The flags are, and then there's some things here, non-blocking operations, close on exec flag, message error queue, queued errors should be received from the socket error. We don't care about that. I mean, I just want to have some basic application working. This is if you do something sophisticated, and if you know what you're doing, not like me here. Okay, let's look up the receive from documentation again. So we need to pass a 0 for the flags. Then we pass a source address, and we already have, no, we don't have a source address. Or do we? Is this address here the source address? I think yes, because here we accept any address. So we receive from socket internet address. It's a bit confusing that this is called the in address, but the in doesn't stand for in. So it's not the address of this computer or some other computer. It's the socket internet address, as far as I know. Let me just pass it and then see if it works. Maybe we need a different address, but this would be my best guess. And then we need to pass the length of that address, and we have already created a variable for that, socket or sock length. And that's it. So here we are passing struct. There's again some error. I will go to my compiler and let's do GCC. Wait, is there already some? Yeah, here. Joystick.c. Out file is joy. Then all warnings, all compiler flags. And let's compile that. And there are a lot of warnings here. So we get an error, incompatible data type for argument 5 from recvfrom. We can't just use the sin address because this has to be a struct socket address, just as in the other method call where we created the bind, I think, right here. And we had to cast it. So let's try to copy that using Vim's V key, then hit yank, Y for yank, and then let me just navigate to the place before that and hit P for pasting it, and there we go. Now it's being cast. And let's go back to the compilation thing here and see if we still get any oh god. We still get messages here, or warnings. We still get warnings. Cannot convert to a pointer type. Ah, of course. Yeah, of course, because we are passing the address, but not the address of the address, which is the topic that we already had. Okay, good. Now let's clear and try to do that again. And we still have a lot of errors, but why do we still have that error? I'm passing the address now. Did I miss saving? Let's try again. Clear. Let's compile. Okay, now the error changed. Passing argument 5 of recvfrom discards constant qualifier from pointer target type. Okay. Yeah, makes sense. Because here we receive from a socket and write into a buffer, and we pass in the socket address, and it needs to be just the structure socket address, not a constant. Maybe the method is writing into that or something, but I'm passing a constant. So we have to remove that constant qualifier here, that constant symbol. And now this warning should be gone. Let's clear, compile again, and yes, we now have fewer warnings. Let me just do this so you can see all of the warnings. Okay, warning. Passing argument 6 of recvfrom makes pointer from integer without a cast socket length is a size t, and it expects, what does it expect? A sock length t. Yeah, that's this. Oh, but we need to pass an address to the length. That's weird. We need to pass an address to the length. Does it mean that this is changing the address, the address length? It seems to be the case because otherwise we wouldn't have passed this as a struct instead of a constant struct. So we had to remove the constant here, and now we also have to remove we have to pass the address to the socket length, which means that recvfrom is probably manipulating the data inside the socket address structure. But that's just a guess. But I think this is a quite valid guess. Let's try to see what happens now. This is yeah, of course, it still wants to use we have to probably cast it explicitly to sock length t. So sock length t pointer cast, and there we go. There's no warning right now in that line of code, and now there's just the unused variable error. So what happens if we execute the application? It prints out hello joystick, as you can see down here, and then it stays open and waits for an incoming message. And now we can actually test this from my phone. Wait. So I have to write into this UDP joystick. I hope it focuses. Wait. Yes, now I have to write the destination IP and the port, which I have to adapt now. So, and which port did we specify? We specified the port 12345. Okay, port is 12345. And then there's another argument, which is this so-called, come on, focus. Anyways, it says send delay. It's this one, the bottom one. And it says it's 4 milliseconds. That means at most there's one message every 4 milliseconds, which is still very, very much, I think. And let's turn that joystick on and go to the joystick menu here, or to the actual visualization, and let me just hit the joystick, and you can have a look at this joystick and at this waiting thing down here. And I think if I do something, oh no, nothing happens. I would have expected that this method recvfrom then receives data and the length is basically met, and then this application terminates. But this seems to be not the case. Why? Where is it waiting? That would be interesting to know. Maybe it's waiting for a bind before we actually send things, and I would have expected that I can properly bind to my computer here. So let's go to the debugger and quit the previous process, and let's restart that. And let's do layout next, and then start next, and let's see where it's waiting. Yeah, I just hit next and it's not doing anything. That means it's waiting at recvfrom. Would be nice to be able to print the buffer, but now I can't do anything here because it's waiting. Now, it seems that is the application working? I can use a different UDP application, which I have used in a different video here, this one, where I can also specify an IP address and a port, and then I can send a message to that. So I will do that now. Let me enter my IP address 17857 and a port. And by the way, I'm using the private IP address of my local network, not the public one, of course. And both my computer and the phone have to be on the same network. Let me just check. Yes, I'm still connected to the network. That means it should work. So let me just send a message, hello. So I have set my IP address. I have written hello here. And let me just send it. Oh, it sent the message, but nothing happened in our code. And that's odd. Do I have to open a port somewhere maybe? No, that shouldn't be the case. So where do I start looking? Maybe the address that we specify here is wrong. Let me just see what this guy on the internet does. And then let's see. So here we bind the server to a socket descriptor. It's fine. we say receive from listen file descriptor. What's the listen file descriptor? It's, yeah, the socket that we created initially, so that's fine. Then it's passing the buffer and the size of the buffer. 0. And then it specifies the client address here. That's the difference. But how do we know the client address? Wait, this is the server. Does the server need to know about the client before running? Client address. And that's the thing that I would have expected, because here it's receiving data from something. Receive from a specific client. But what if I just accept everybody to send things to a socket? Wait, is that maybe the difference between receive and receive from? Let's look up the documentation. Is there anything useful here? Okay, receive from. If source address is not null and the underlying protocol provides the source address of the message, that source address is placed in the buffer pointed to by source address. Okay, so the source address seems to be important, of course, because we say we want to receive something from. If the caller is not interested in the source address, which is the case for us, I don't care where the message is coming from. It needs to be just some remote control. Then source address and address length should be specified as null. Aha. Okay. I love it when I read documentation and I understand it without looking it up on the internet. Okay. That means we can do null here and null there. And then now we can probably run the application, compile the application and run the application. Now we get the unused variable warning, of course, because we don't use that error code here. Maybe I will remove it. We don't need it. Let's just assume everything works perfectly fine in our code. If you create production code, then of course you have to specify, or you have to check for errors. So here it's waiting for the joystick connection, and let's send a message. I will just use the same plain UDP message sender here. Oh, come on. Anyways, I will just hit send. Just trust me that I'm hitting send. And let's go. And it's not doing anything. Maybe because I need to reconnect. Do I need to connect somehow? Okay, I will close the application, open it again. So there's the host, the port, the message. Let me just send a 4-byte message because that's what we specified here, which doesn't work because here we are expecting. Wait, what did I even do here? What kind of message am I expecting? I have specified a buffer and an expected length of. No, wait. Let's keep it very simple. Let's create a character buffer. Character pointer, size of character. We have allocated 4 bytes here. At the end of this application, when it terminates, we can free that buffer again. So let's pass that here just to complete the code. Okay, now we are waiting for size of character multiplied by 4. So we are waiting for 4 characters. 4. So the expected length is 4. So let's multiply the size of with the expected length. That means I'm now waiting for 4 characters. Let's compile and let's send 4 characters. 1, 2, 3, 4. It's not doing anything. Why is it not doing anything? Let me think for a second. If the caller is not interested in the source address and address length should be specified as null. The receive call is normally only used on a connected socket and is equivalent to this call. It's the same as receive from, null and 0. But here it says address length should be specified as null. Okay, let's try that desperate attempt to set this as 0, which is the length, the expected. What is it? It's the length of the address. Let's run the application. Send something. Wait. We are receiving data from the buffer, but what are we expecting the program to do after that? Once the buffer is full, does it... are we even expecting the application to terminate? Because actually I would expect this to work now. It's completely... The code is looking completely reasonable to me. What does receive from return? It returns a size t. Let's search for return. All 3 calls return the length of the message on successful completion. If a message is too long to fit into the supplied buffer, access bytes may be discarded depending on the type of socket in the message. Depending on the type of socket the message is received from. Something is wrong somewhere. Maybe I have the feeling that I'm not really listening to all incoming connections. Here, this guy specifies internet address and then itself. What is this used for? That's the client code. Here, this guy is also receiving things from somewhere. From whom? From null. Okay, I think I've understood part of the issue. So I've just installed Nmap, which is a networking utility, on my computer, And because I'm using a Windows computer and I'm running all of this development stuff here in the Windows subsystem for Linux 2, that it seems that the networking from Windows is not always visible to WSL2. So even though we're listening for UDP packets here, it might not be the case that my Windows machine that is actually hosting all of this is forwarding those packets to the Linux machine. And to show that, let me just show you. So this is the installation directory for nmap, and if we just hit command here, so here you can see that if I do the following, ncat, then ulp, and I listen for UDP messages on port 12345, and now I go to my UDP sender, then let's just send a message. And I'm just writing, here it works. I hope you can see that. Here it works. And now let me send that. And there the message pops up. So here it works. Let me send it again and again and again. It doesn't print a new message here. Maybe if I add a character. No, it doesn't seem to be the case. But for some reason, well, here it works, and here it works too. Yeah. I don't know why it doesn't print new messages if I change them. Let me just write changed. If I send that now, it doesn't do anything. Okay, anyways, but at least we can verify that there's a connection here. If I do I have netcat here? Yes. Then I do ulp, and I do the same command here. Oh, it says address is already in use. Why is the... Wait, the address is already in use. Maybe it's just a process running in the background that hasn't been terminated properly. What if it's this thing that is causing the entire trouble? Wait, if I kill this process 435, I don't even know where this was running. There's still GDB joy in the debugger. Let me quit that, just to be sure. Oops, what's that? Oh no, I messed up my terminal. Okay, so this is the debugger terminal for later. So, is there any process running? No. If I do the netcat command now, it's listening. Can I send a message now? No, I can't send a message now. I'm trying to send a message. Okay, so at least we were not blocking ourselves. Okay. So that means the UDP connection is working. It's just not being forwarded into my Linux virtual machine. And to fix that, what can we do? I have to look that up. Okay, it seems that there's this networking mode mirrored in WSL2 that we can use. So basically Windows is forwarding all the network requests to the Windows subsystem for Linux. And I will set that up. And once that is set up, I will return to recording this video, because this is really not the scope of this programming tutorial. This is just my local system and configuring it. So see you in a second. Oh, and this is just a quick jump in. I have found in my settings for the Windows subsystem for Linux, just to show you, just in case you need this as well, there's this networking mode, and this is the issue, I think. Here we specify the networking mode for WSL, and we have to set this to mirrored and then restart all of the WSL thing using a command. And we can see that here. WSL shutdown. So I will do all of that and then come back. Okay, and now let's try to send the same UDP packet to the same command netcat listen UDP port. I think that's the logic of that command. And let's send a message UDP for WSL2. WSL2. Okay. And let me send that. And there we go. That's it. So now we can finally, after all that hassle, receive UDP packets, which is awesome. And now we have to verify that our application actually works, because now we should be able to do the compilation and execution of that command. So now it's waiting for incoming, So now it's waiting for incoming connections, for incoming messages. And let me just send the same message again to that port. And here it's not doing anything. It's probably because that process is still running. So maybe the binding was failing, I don't know. Okay, let's try again. I'm sending. Oh, and now the application terminated, which means that the message was received. Awesome. And now we can print the content of the buffer, probably. How do we do it? It's a character pointer, which means it is a string, so we can just pass this as a string probably. Okay, let's go. And I'm sending the message UDP for WSL2. And as you can see, we received UDP and a space, and that is because we have specified that we expect a length of 4. So we can also increase that a bit. Let's just make it 100 bytes and see how this performs. So let's send the message, and it received the entire message and also understood that it was not going any longer than that, and then terminated. Perfect. Now, the next step would be to send a message from the joystick application. So I'm going to the UDP joystick here. I'm setting my destination IP and port. I'm going to that joystick, and let's hit the screen somewhere. And nothing is happening. Why? Oh no, I expected it to work. Destination IP is correct. The port is also correct. Let me restart that. Joystick. And that's not sending anything for some reason. Can we just cross-check this with the netcat thing? Here we're also not receiving anything. That's interesting. What if I open netcat on Windows? Because just to cross-check that this is not a Linux issue. So where is it? Here, command. Let me open the Windows command prompt. There we go. Then netcat listen UDP port 12345, and let's see. Yeah, nothing is happening. why is this application not working? Maybe this application is not good. I'm definitely not receiving anything from anywhere. So I think it's time to pull up. Wait, where did my browser go? Here it is. UDP joystick Android. There it is. So this is the app I used. And here it says that we can specify a destination IP. Okay, it's a simple application which is used to communicate with other devices by sending UDP packets with positions data of two controlled joysticks, touchpads. In applications, you can choose the speed delay of sending packets and automatic centering access on release joystick. Is it even working? The UDP packet format it seems to be a string. So there is documentation, which is good. But it seems to not send anything. Let me just be very sure and close all applications on my phone, because I would be surprised if this application is really not working. And then let's make sure that we are not connected to any port here. Okay, no processes running that looks suspicious. Then let's run the application. Oh! And I think I missed pressing this blue button here, which says on and off. Yeah, okay, I missed turning on the joystick. So this means we received here the first UDP packet from our joystick, which contains a string. It is a string apparently, with 4 positional arguments, as you can see, which means we have 4 entries, and each has a size of 4. That means it's 16 bytes. No, 16 characters, which is effectively 16 bytes on, I think, all systems. So we are expecting 16 characters. It's awesome to see some progress here. Then what we can do is we can now loop while true. So we loop forever, and then we just printf the string that we have received. Printf, and then of course a new line after each packet, and then we input the buffer. So let's run that application, and as you can see, it's printing a lot of stuff, but I don't get why. I think I know why. Because I just put a while true loop here, an infinite loop, and just printed nothing because the buffer is empty, and only here I receive stuff from the UDP protocol. So let's do it properly now. Okay. And I would say instead of sending data every 4 milliseconds, I will set it to once every 200 milliseconds, because otherwise it's way too much for our small little application. Let's run the application, and as you can see, we are receiving arguments now. I'm going to the joystick, and now I'm wiggling around, and as you can see, some numbers are changing, which is awesome. And now I stop, and now the numbers stay the same again. And now I modify both joysticks, and you can see the numbers changing again. So what we need to do now is we want to have a real remote control that actually visualizes what we are doing. So now we are receiving data from the joystick. And now let's make this very powerful here. So this is the main method. This is the setup of everything. No, before we continue with the graphics, I want to parse this. I want to split this string. So how can I do that? I need a browser again. UDP C split string. Yeah. But this splits the string based on a delimiter. Actually, we have 4 different values. Wait. We have 4 values. They are and they are integers. Let's say they are integers. And they are, let's call them x1, y1, x2, y2. They are currently unused, obviously. And now x1 is equal to the first 4 characters in this buffer. How do we get the first 4 characters in a buffer? Get part of string in C. Get a substring. Oh yes, substring is what we need, of course. I always forget these terminology. Printf. Yeah, we could manually loop about over that, but that would be horrible. There's a destination thing here. Oh, it's so much. String. We can use string. No. Substring in C. So we use string copy substring. And we copy into the substring the string plus 7. So string at index 7 and then a length of 5. String coming from string.h. Okay. So basically we can copy this include statement here and just remove the s. And all of this is just receiving stuff. Yeah, anyways. And now we can do string copy, strn copy. strn copy. And let's open a manual for strn copy. So there's the string copy, which copies a source string into a destination string. And there's string n copy, which copies just n characters into the destination. Fine, which is basically what we need. So we want to copy into. And maybe we should make all of those character pointers for now. So I want to copy into x1 from the source string. What is the source string? The source string is the buffer, 4 characters. And then I can print f x1. Ah, bullshit. Not good. x1, like this. Why is it saying that the variable x1 is uninitialized? It's a character pointer. I have to allocate the memory, of course, first. I think maybe we don't even need that many variables. I actually just want to wiggle one thing around, so we need just one joystick from both. We don't need both joysticks for our little application. So let's do character pointer x1 is a character pointer, obviously, malloc. And we allocate size of character multiplied by 4. Let's just hard code that. Then we do the same for y1. And then at the end of the application, we of course free x1 and y1. So we string copy into x1 from the buffer, and we string copy into y1 from the buffer, but at a different index, at index 4, but still a length of 4. So let's run the application. Oh no, before we run the application, we want to print both x1. x1 is equal to this, and y1 is equal to this. Not this. This is a string. And actually now we don't need the 1 index here, because we just have 1x and 1y. We just need one of both joysticks. Okay, there's of course still an issue here. Now it should be good to go. No, still not, because in the free statement I also messed this up. Alrighty, then okay, it seems that we are now properly reading the coordinates. And now I'm using the first joystick because we're just extracting the first x and y coordinates. And now I'm changing them, and as you can see, they are changing on the screen as well. How awesome is that? Oh, sorry. So that's awesome. Okay, so now we have changing x and y coordinates. I just want to convert them to actual numbers. So I can print them using not the S thing here, but using this D. But maybe for, no, we need it rather sooner than later. So let's see, convert string to int. There's the a to I function that converts a character string to an integer value. Okay, a to I. There is also string to long. No, let's just stick to the classics, and let's create an int variable, int x I, and x is nothing, and y I, and then we do x integer is a to I of x, and y I is a to I of y. I don't know if that works. There's a warning. Variable yi is set but not used. Yeah, so yes, we need to change those for the integer representations in the printout. And we print xi and yi. So they are the integer variants of the original data that is incoming. Okay, x is apparently 2000. I don't know if that, yeah, it is 2000 on my joystick as well. It's the top left corner. So yes, it's 2000 and the other one is 1293. And if I change that, if I do something on that joystick, then the numbers will change accordingly. So it seems that we are properly parsing the data. And now this completes the entire UDP part of this project. And now let's make something move on the screen. And all of that is just graphics fun. Fun with graphics. So let's include SDL2, SDL.h, which is our graphics library that we're going to use. Here in the beginning of that program, we're going to call SDL init. And we're going to initialize the video subsystem. Then SDL create window. And it should be called joystick controlled game. Or well, UDP joystick. Let's call it UDP joystick. Then we are creating a window, and let me pull up the documentation for SDL2. Create window, and the first argument is the title. The second and the third ones are the x and y coordinates, and then width and height and flags. So we're going to create the window at the SDL window pos center of the screen. So centered, we're going to pass that. Those are predefined constants, which everybody can use. And then we're saying this is our window width and this is our window height. And then let's define the width as 900 and the height as 600. There's some error in the header. I don't know what it could be, but let's just continue and see if any error pops up later. Maybe we can even start the application and it doesn't compile, obviously, because I haven't included the SDL header flags. So the compiler doesn't know how to link this. So let's open SDL2 installation, and there we can see some instructions on how to compile this, and we have to add those flags here. So basically, let's just copy them and see if it works. And it doesn't work. Obviously, because we have forgotten to pass the flags to the end of this create window statement. And now let's see. Note define width. This is the location of the previous definition. Oh, I have messed the definition up. Width and height, of course. And what else is there? Oh, nothing. That's it. So we now have this window, and here we're going to draw a simple rectangle that we can move around on the screen. And if this works, this will be awesome. But now the application doesn't terminate. How does it terminate? Oh no, I have to probably kill it. Right. PS orgs, grab Daniel, and then let's kill joy, which is this one. And there we go. Now it's gone. Okay. Now we have this while loop here, and it shouldn't run forever, otherwise the application cannot be killed. So we need an integer that says game is running, and it is true. And while the game is running, we do all of that reception stuff. But we also need to fetch for SDL events. So let's do that. SDL poll event. And here we pass an address of an event. We need to create that in a second. And then we need to check if the received event, if the event.type is SDL quit. And if the event is quit, that means if someone tries to quit the application, then we actually set the game running to false. And we have to create the event here. SDL event is event. We don't need to enter any data. It's now being filled here. And then SDL delay. We can delay this. Maybe 20 milliseconds. Just so that our computer has some time to breathe. So now this is the applications window. And we can quit the application like this and it's done. Okay, that's already very good. Then next step is we want to create a rectangle. Actually, that's already almost the last step. We want to create a rectangle. To do that, we have to get a window surface from the window. So that is the black part of the window that we want to draw on. So let's get that. SDL surface p-surf. Yeah, that's going to be a pointer, I think. Ah, no, what am I doing? First of all, we have to get the window. SDL window, p window. So that's the window. Let's try to compile this without executing it. And there's a warning that it's an unused variable. That makes sense because we're not using it yet. Then we need an SDL surface, p surface, and that is coming from get window surface. If you want to know all the details of SDL, then I highly recommend you check out the other videos on this channel where we dive into much more detail here. And you learn a lot about graphics programming. So as you know, as you can probably sense now, I have done more graphics than networking before. That's why the networking part took so long and the graphics now goes a bit faster. Okay, so SDL surface, no, SDL get window surface should be, wait, create window, SDL get surface, no, SDL get window surface. Ah, there it is. I somehow missed it. And then we pass in the window and then we get the window surface. So that is the black part where we can just write raw pixels to. And then we do, whenever we receive something, whenever we receive data, we create a rectangle. And maybe I should create a structure out here. SDL rect is a rectangle that we're going to draw on the screen. And that's a structure, struct SDL. Or maybe SDL rect is enough. No, let's keep it struct just to be safe. Rect. And that is a structure SDL rect. And it has an X and Y position. Let's say 50-50 and a width and a height, which are also 50. So this is a small square and we can call the fill rect function to fill on the surface the rectangle. Here we provide the address and then a color, and the color is just going to be white. FF, 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 FF. Good. And then after drawing the rectangle, if we just execute the application as it is now, nothing will happen because the rectangle is not being drawn on the surface. It's just written into it's just now stored in the memory. Oh, somehow we can't quit it. Do I have to first send stuff here? Oh, something's wrong. Kill the joystick. 671. Okay. we have to tell SDL to update the window, because only then it will take the memory and write it into the video memory. Update window surface p window. And I think that should do it. Let's just try to compile. There are no exceptions or warnings. And let's try to create the application, and there it is. This is our small little rectangle. And this is our remote, which I'm wiggling on right now. And as you can see, the coordinates are changing. Now, we want to move the rectangle on the screen, but those coordinates, they don't fit the width and the height of the screen. So the coordinates here that the joystick passes are somehow between 1000 and 2000. I have no idea why, but they need to be between 0 and the width and height of the screen, respectively. So x needs to be somehow normalized to the width and height of the screen. So we have to adapt x and y to width and height. And then we have to update the rect's coordinates. And then once that is done, the rectangle should be moving. So xi is equal to the original xi, but it should be I want to reduce it by 1000 because for some reason this coordinate starts at 1000, so that is the minimum number. I want it to start at 0 and go up to 900, which is the width. So minus 1000, and then it should be maybe multiplied with width divided by, well, actually we can just do this. That's not very robust code, I think. I will just do it for now and no, it should be the width of the screen divided by 1000. And this should be the height of the screen divided by 1000. I hope this is correct. And here this needs to be a double operation, and this needs to be a double as well, just so that the final result is correct. Let's see, we don't have a rectangle right now. Now we have one, now that the joystick connected. And now I'm moving the joystick around and nothing happens, of course. How can I forget all of that stuff? Okay, I need to update the rectangle's coordinates. So we do that under here and just write rect xi is equal to that's not correct. Rect x, the x coordinate of the rectangle, is equal to xi. Yeah, my brain is really becoming slow after all of this coding now. Okay, but I think this should be it. So I hope this is the final test. Let's go. Why doesn't this work? I'm using the arrow operator. I need to use the dot operator. I thought the rectangle was a pointer because we're passing it as a pointer here, but of course it's not. Okay, so I hope this is the final test. My joystick is connected, I think. Let's run the application. The rectangle is not visible on the screen and I can't see it, so this is not the final test. What's wrong here? I'm sure that I have messed up xi and yi. Of course I have. And then maybe there's, oh, no. Okay, wait, let me introduce you to this a bit. So now, I hope this is the final test. If everything worked out, then in this video we have coded a UDP receiver, which basically lets you remote control an application. We have parsed the UDP data, which is being received here. And now we are visualizing the parsed data in SDL using this small rectangle. So let's just try and wiggle the rectangle around. And as you can see, something is happening. The issue is just, it's quite nice that I'm drawing on the screen via my phone. The issue is just that we are drawing new rectangles all the time, but we are not updating the old ones and deleting them. So we have to also do fill rect, and then we have to pass in here null to fill the entire screen, and we make it all black. I think it's done something like this. Okay, let's try to move it. And as you can see, I'm now moving the rectangle in a circular motion. It's just very laggy. I don't get why. Maybe because I'm sending only, as I have said earlier, from my phone, a packet every 200 milliseconds. Right there. So I'm now reducing this again to every 4 milliseconds. So I'm really sending a ton of packets now. And let's restart the application and let's go. So joystick, and let's try to move the rectangle. Oh, it doesn't do anything. Why? Is it receiving too much? So I have to kill the application, 82. Okay, I'm increasing the delay a bit to, let's say, 20. Here I'm filling the rectangle. Maybe I have to fill it with a new rectangle that I define simply up here, which is, wait, where did I define the original rectangle? Ah, there it is. So I will define a new rectangle that is called the background rectangle, which is basically covering the entire background, starting at 0, 0, going up to width and height. And now I'm updating the background with black, color black. 1, 2, 3, 4, 5. I think I missed a 0 here. Let's check the joystick application. Oh, okay, now I'm connected. Let's see if I can move this rectangle around. And I can move it around. But why is it getting stuck? Is it maybe too fast? I think maybe it's too fast. It's trying to process a ton of information here. And I think the SDL delay here is interfering with the delay that the UDP packets are arriving. So let's remove the SDL delay, because we already have this blocking operation here, the receive from. And let's try again. And now I would expect it to work. Wait. So now it's turned on. And I'm moving, the rectangle is moving on the screen. I don't know why it lagged. Now it seems quite responsive. Yeah, I think that's fine. So guys, let me draw a heart for you. Heart shape. And that's it. So we have coded this application That's awesome. And I'm also quite happy that this video is finally done, because we have coded so much different stuff. We have coded networking, these basics of game programming here, and it's really a lot of content. And as you can see, I'm now moving the rectangle using this joystick on the screen, and it follows my finger. How awesome is that? I can even move it off the screen, I think. Yeah. But not to the left-hand side. All right. If you enjoyed this, consider becoming a patron, because this is what really keeps the channel alive. And if you don't want to, you don't need to, but at least leave a like and become a subscriber, because we're always exploring incredibly interesting things on this channel. And this is something that I particularly enjoyed, because this result is just so responsive, and no, it's so visual. Okay, and if you enjoy those kinds of projects as well, then stick around. See you next time. Bye.